So in section 3.2, we talk about the graph of a function. So this is part one. We're going to use first or discuss first is something called the vertical line test. Now the vertical line test is what we're going to use to determine if a graph represents a function. So I have the graph that's on the top of the handout drawn on the board, and I want to know if that graph represents a function. So we're going to use this vertical line test. What this means is if you run a vertical line, which is essentially, a straight up and down line, and you run it along the length of that graph, it should only intersect the vertical line once all along its length. So if we do that, we'll notice that no matter where I stop my vertical line, it's only intersecting the graph once. So once there, once there, once there, once there. So yes, indeed, this is a function. And that's the vertical line test. Very handy to show it at a glance if a graph represents a function. So this one's definitely a function. Now that we have a function, we need to be able to read the graph of a function and pull information from that picture. So again, I urge you to take a look at the handout that I provided. It's this picture, but it's larger and you can see what's going on. The first question that's asking us is to find, first of all, find f of 0. Now, that's the input, that is your x. So what they're asking me for is when x is 0, so x is 0 right here, they're asking me for the corresponding y value. So what's the y value when x is 0? Well, the y value is a positive 3. So f of 0 is 3. So I don't have anything to plug into to give that to me. Instead, we're pulling that information from the picture. So f of 0 is 3. Again, that was an input of x. I go up to where the picture is, the graph itself, and I see that the corresponding y value at that point is a 3. So that gives me the point 0, 3. So what about f of negative 6? So again, the input's negative 6. I'm going to come over here to an x value of negative 6. I'm going to go down to the picture, and I see that the y value is a negative 3. So f of 0 is 3, and f of negative 6 is negative 2. So again, you simply go to that x value, go to the graph, the curve, and find the corresponding y value. Part B is asking a couple more of those types of questions. So it's asking us to find f of 6. So I come out here to 6. 6 is right here. On my picture, the corresponding y value is 0. And to find f of 11, I go out to an x value of 11. I go up to my picture, that's right here. And the corresponding y value is a 1. So we're evaluating a function without ever having something to plug the function into. Instead, we're plugging the inputs into that picture, the graph. Part C is asking us whether or not f of 3 is positive or negative. So again, they're giving me the input, an x value of 3. When I go to an x value of 3, sure enough, I'm up here at a positive y value. So an x of 3 corresponds to a positive y value. So f of 3 is positive. Part D is asking us, is f of negative 4 positive or negative? So f of negative 4. So the input is a negative 4. I'm going to come over here to an x value of negative 4. At negative 4, I'm having to go down to get to the graph, the curve. So that is a negative number. It's simply saying that the output is a negative y value. Part E, so they want to know for what numbers of x, so what x is f of x equal to 0. Okay, this time they're giving me the output. The output, which is y, is 0. So I'm looking for y values of 0. Well, if I'm right here, the y value at that x-intercept is 0. So one of the x values is negative 3. Wait a minute, is that the only place where y is 0? Well, no. Over here, y would be 0 also. That's at 6. And then one more time right here, y is going to be 0 at 10. So when x is a negative 3 or 6 or 10, the corresponding output is 0. That's a different way of asking the question. F says for what the numbers of x, so what x is f of x greater than 0? So not equal to 0, but greater than 0. Well, greater than 0, this means that the y values are positive, right? Greater than 0 is positive. So where are the y values positive? Well, this is anytime I am above the x-axis. In other words, it's positive anytime we're up top. Well, where is this thing up top or above the x-axis? Well, starting over here at negative 3 and moving at 6, all of those values are above or positive y values. So we're going to go from negative 3 to 6. I'm going to use parentheses because of that greater than. Okay, what about this guy? Isn't this also above? So we're also above the x-axis from 10 to 11. So we're going to have union 10 to 11. question G, or part G, I guess I should say, asks about the domain. So again, the domain is the set of input values. So we are asking you, what are the set of X values that we can use? So your domain is always the left side of the graph to the right side, left to right, the set of X values that are being used, so left to right. Well, the left side of our picture starts at -3. Because it's a closed circle, we're going to use a bracket. We're using every X value in between all the way over to the right side, which is 11. So our domain is -3 to 11, left to right, always in numerical order. Part H is asking for the range. Well, the range is the set of Y values. That's the bottom of the graph, the top of the graph. So because you need them in numerical order, you're going to pick up the bottom first and go to the top. So the bottom of our graph, well, here's the bottom of my picture. This picture is over here at -3 because this was the point -6, -3. So the bottom of the picture is at -3. We'll use a bracket again because it's closed. Uh-oh. So that means, sorry, in hindsight, it's because I labeled it wrong. This is -6. So you're probably screaming at me. No, wait, that's not right. The X value is -6. Sorry about that because I didn't label the point. I just picked up that value, but that's the Y value. So make sure you pick up X's. So this is an X, that's an X. It's a range of numbers. Over here, we have -3. Let's make sure it gets labeled right. This is 11, 1. So we're at 1 on the right side or the top side. So the bottom of the graph is this -3. Is the top of the graph the 1 or is the top of the graph the 4? Well, wait, what's the largest Y value we see? Is this point over here, which was at what, 2, 4? So your range is going from -3 on the bottom to 4 on the top. So again, notice that the left and the right and the bottom and the top may not line up points wise, but again, left to right, -6 is the leftmost X value, 11 is the rightmost X value. The bottom Y value is -3. The top Y value, the largest Y value is 4. Sorry about that. I asked, what are the X-intercepts? Well, the X-intercepts are easy. That was -3, 0, 6, 0, and 10, 0. We'd already identified those when we answered part E. What are the Y-intercepts? Well, it's only got one. It can only have one Y-intercept. If it has a second Y-intercept, it's looping back to that Y-axis, and it wouldn't be a function because it would fail the vertical line test. So the Y-intercept is at 3. So we're going to write that as 0, 3. Again, remember, intercepts are points, not numbers. K asks, how often does the line Y equal to 1/2 intersect the graph? Well, Y equal to 1/2 is a horizontal line, and it's a horizontal line cutting through right here at 1/2. Well, it touched that graph or the curve 3 different times. So part K is 3 times. Part L is asking, how often does the line X equal to 5 intersect the graph? Well, wait a minute. X equal to 5 is a vertical line, and because this is a function, this better be just one time. So I'm going to come over here to 5 on the X-axis and draw a vertical line. And sure enough, it only intersects the curve one time. So it's a function. So this is one time. Finally, 2 more questions about this wonderful little picture. Your homework gives you a different picture and asks you the same set of questions, basically. M asks, for what value of X? So what X does f of X equal 3? Okay, well, they're giving me the output. So this is the Y value. And they're asking for the corresponding X value. So I'm going to come up here to a Y of 3. Oh, look, here's one right here. So here's a Y value. That happened when X was 0. I'm going to write it as X equals 0. But is that the only time? Well, we're also going to happen over here. And that point is at the point 4, 0. So also at X equals 4. So both an input of 0 and an input of 4 give me an output of 3. So here's the point 0, 3. And this is the point 4, 3. And finally, part N, the last part says, for what value of X does f of X equal -2? So again, notice they're giving me the output, the Y value of -2. So I'm going to find -2 on the Y-axis. I'm going to go over to my picture. So definitely over here, it looks like, and that was the point -5, -2. So the Y value is -2 and the X value is -5. Is that the only point where it does it? To double check. Wait a minute, over here, isn't this also a Y value of -2? And that is 0.8 comma -2. So that's equal to 8. So over here at 8, -2, we have y values of -2, -5, and +8. That was a lot of parts to that.